Okay, guys, let's take a look at our first section here. So we're going to define for you the what power function. Your notes look like this. First page. Okay. So the what power function based on the sub number. Okay. Sub number meaning the subscript or the smaller number right next to. So when it says what power, the base here 5 would be the sub number. State the power needed in order to get the value in parentheses. So for example, what power base 5 of 25 is stating, hey, what power would we raise 5 to in order to get the value of 25? And the answer would be 5 to what power is 25? 2. Okay. And so you're coming up with the exponent that's going to make it work. Okay. If it helps, this another way to ask this question is 5 to what power is equal to 25, and we can see, well, x has got to be 2. Okay. And so then we got to know something about, we got to know our powers. And so 2 to what power is 16? 2 to the 4th power? Okay. You could try it out. 2 times 2 times 2 times 2. That's going to be 4 times 4, which is 16. So yes, it's going to be 4. Okay. What power base 3 of 81? What would the next one be? What power base 381? 3? So this is asking, again, 3 to what power is equal to 81? Right? And you may have to try it out. 3 times 3 is 9. 9 times 3 is 27. So 3 is not enough. 27 times 3 is 81. And so it's going to be to the 4th power, because 3 times 3 times 3 times 3 equals 81. Okay. So what power base 10 of, is that 100,000? So there's power with tens. What's 10 squared? You get a 1 with 2 zeros. 10 to the 3rd, you get a 1 with 3 zeros. So if you count the zeros, you know what power you're going to need. How many zeros do we have? We have 5. So 10 to the power of 5 is going to equal 100,000. Okay. Okay. How about this one? What power base 3 of square root of 3? Good. Okay. This is asking 3 to what power is the square root of 3, and we've learned in the past that 3 to the 1/2 power is equal to the square root of 3. That's just another way to represent that. So my answer is going to be 1/2. So fractional exponents, remember fractional exponents create roots. So if you have 1/3, that would be a cube root. 1/4 would be a 4th root, so on. How about this one? Zero. Good. Because this is asking 18 to what power equals 1. And anything to the power of 0 is going to equal 1. Right? So we know that 18 to the power of 0 is 1. And so our answer is going to be 0. $25. What power base 25 of 5? So this is asking 25 to what power is 5? And we know the square root of 25 is 5. And so 1/2, because 25 to the 1/2 power is the square root of 25, which is 5. So 1/2. Okay, what power base 1/3 is 1 over 27? Three. So 1/3 to what power? So 1/3 to the third power means 1 to the third over 3 to the third, which is 1 over 27, and that worked out. So 3 is correct. Good. Try this one. What power base 2 is 1 over 32? Anybody have an idea? 5. Okay, well we know that 2, let's try it out. 2 to the 5th power. What's 2 to the 5th power, guys? That's 32, but we want 1 over 32. So we can make a minor adjustment here. And if you make it a negative exponent, so 2 to the negative 5th power, that's going to be 1 over 2 to the 5th power, which is 1 over 32. And so we need to remember what the negative exponents do as well. Negative exponents give us the fraction, right? Or the reciprocal. And so our answer would be -5 for that exponent. How about number 9? Try number 9 out. What power base 0 of 5? What do you guys think? Nothing? Because this is saying 0 to what power is equal to 5? So maybe infinity. 0 to the power infinity could be anything. Actually, you'll learn that in calculus. But we're only working with we're going to only work with numbers. Infinity is more of an idea, right? So this isn't this. There's no solution to this for us. Okay. Okay. And so it doesn't make sense when our base is 0. It does not work when the subscript, and I'm going to call that the base, equals 0. Okay. Example 10. Try that one out. What are we getting? 3. What are you guys getting for this one? Same thing as what? Okay, so it's not working because this is saying 1 to what power is 9? And 1 to any power is equal to 1, not 9. So this is not going to work. And so there's no solution to this as well. Okay. It's not going to work when the base is 1. Try 11. What power base -2 is 32? Or you could think what -2 to what power is equal to positive 32? -5? Let's try. If I go -2 to the -5, what is that going to equal, guys? 1 over -2 to the 5th, which would be -1 over 32. So that wouldn't work. No. If you flip it, the exponent becomes positive, but not the number. Just the exponent. Okay. Is this going to work out? No. If we do -2 to the 5th power, we end up with -32. That's as close as we can get to it, but it's negative. No way to avoid that negative. So this, again, no solution. How about this one? 4 to what power equals 0? Is that possible? Again, not possible. No solution. So, what is different about examples 9 through 12 versus 1 through 8? How are 9 through 12 different? They all are no solution. Can you make any generalizations? What's making them have no solution? So let me start here. We will have no solution if the base is what? What are some of the things? So the base is a subscript. What's going to make it not work? If the base is 0, what else? The base is 1. Now, could it work if the base is negative? So if the base is negative, we're going to have to talk about two things. So we'll talk about this as the base, and we'll say this is the input, okay? So if the base is negative, and this will be our answer, okay? When will it work? If the base is negative, the input is positive, and the answer is odd or even? Even, right? So if you have one that works that way, here we had an odd answer with a positive input. If we have a negative base and a negative input, we're going to need what kind of answer? Odd or even? Because if you look at it, you got -2 to the power of 1 is going to be -2. -2 to an even power is going to be positive, right? -2 to again 3 would be -8. So if your power is even, you're going to get a positive result. If your power is odd, you're going to get a negative result. And the power is actually the answer. This is the power of our exponential function. So this is a little harder one to write up. So if we have a negative base, positive input, and it's not going to work if we have a what? Even or an odd? Odd answer. Okay. So that would fit example 11. And then what about example 12? What's that? This really has more to do with the input. If the input is 0, it's not going to work out. All right, so those are some cases that will make it not work for us. All right, that's our notes. Let me get you the homework.